I propose for my assignment. As you can see, this is my serverless application architecture utilizing a number of AWS services. I've tried to follow a kind of microservices style to create the application. Um, this is just an architecture diagram I've included in my report so you could analyze it later. Now onto my actual application. It's basically a news and weather app which performs getting and sending data without an API of my own. So basically, how this application works is, uh, ideally I should be using an API gateway to make things work, but Rosetta restrictions, so I could not use it. So here, what I do is once you click the submit button, it invokes a Lambda function. I used AWS JavaScript SDK to invoke the Lambda functions from the browser, and here it gets the data according to the priority. This is the news service, this is the weather service. They both operate independently without depending on each other. So nothing fancy happening here. You post the data from here, and it invokes a Lambda function, which again invokes another Lambda function, which we will see in our console. So back to our console. These are the number of Lambda functions I've used for my application. I think from the name you could make out what functionality they would offer. This is post weather lambda, which would, like the name says, would post weather data to a database. And yeah, so I have included all of this in my reports, and I really have a short time, so I don't want to go into deep and explain them. So basically, what my application does is, once you input the data from here along with the priority, my lambda function checks for the priority. If the priority matches a given condition, for example, if you put the priority as high here, it will send that as a message to the SQSQ, and SQSQ would invoke another lambda function which sends an SNS email through email or a message SMS through SNS queuing service, sorry, SNS simple notification service. So these are two SNS SQSQs I have used here, and to see them in action I would write some news headline. um, and I would give it the priority as high. Now ideally what happens in my application is, once it checks for this key priority, if the priority matches the given string, it sends this priority to the SQSQ, to the news priority SQSQ, and this triggers the lambda functions. Like so I've added a trigger for this. This triggers this lambda function send SNS email, and if you see this lambda function send SNS email, what it does is, it sends an SMS to the mobile number I mentioned here, and also have manually added a subscriber by email. I could show you that. And I should be getting an email on my other email ID. So what I'll do is I'll post the data from here, submit. Now the priority is high. Now let's check if I am being notified. You see, I got a notification here about high priority news arrived, and this happens through SNS. This is the function which sends the message, and also an SMS to my mobile number. I can't show you the message through my mobile number, so I've included it in my reports. And similarly, if I enter a weather condition, for example, if the weather is over 50 degrees, that's the condition that I have set, I should get a notification on my email, and that happens through another queuing service. It's called weather parity check queue. So the application was to keep the functionalities independent from each other. Every service will operate on its own without having a dependency in between them. So ideally, if there are more than 1,000 people working on an application or inputting data through this device, so there will be two different queues maintained, one for weather, one for news, a sort of a microservices style. So let me just quickly enter the temperature here. So according to my condition, if temperature is more than 50, I should get a notification on my email, on another email ID. Yeah, that's the higher priority weather arrived. So these are two services sending messages to different subscribers, and also I have included a schedule lambda function that basically gets triggered. Send whether shall, yeah. This Lambda function basically gets triggered by CloudWatch event. So I've used a cron job to schedule this event where on every day at 9 p.m. it fetches the data from the DynamoDB and sends that as a message in the message body in the email. I have attached let me check if I have it in my email. Yeah, see. So this is the example where it has sent me the JSON data as a message, and it gets triggered on 9 p.m. every day. That's according to my cron job. Also, let me check how much time I have. I can't really check. Anyway, so this is my CloudWatch custom alarm. So one unique function I have used in my application monitoring is CloudWatch custom math metrics, and I have included all the formulas, whatever I have used to come up with this invocations in my report. But basically, it gives me an advantage over the default metrics. That is, the default metrics are errors, and invocations. So if I want to find the error rate, I divide the errors by the invocations, and I get the error rate. I get the error rate. So this is what I get the error rate, and similarly have utilized some DynamoDB news read and write capacity functions to combine and come up with a new metric. These are called custom math metrics. It's comparatively new, but it's very handy. I don't want to use Python or Boto API to write my custom metrics to trigger Lambda function, so this was a easy way to go. But it's easy, but it's really interesting. Considering the amount of function it offers, and this is my scheduled rule. This is my cron job cron expression, where you see it gets triggered every day at this time. It's sorry, it's not 9, it's 6. I have to change this. In my report I have written 9, but you get the point. It gets called out on whatever time I schedule in the cron expression. These are my SNS topics for queues. So every topic would have particular subscribers. So here is an SMS, that's my phone number and email ID of the subscriber. Other queue, other this thing has my email address as a subscriber, and so that's basically it. I think I've covered. I have from the given time. I think I don't have much time to cover anything else, but everything else have I included in the report. So if you guys want to evaluate this further, the reports are always there. And let me just think if I forgot to clarify anything else. Yeah, this is my database DynamoDB. So I thought, when I'm using a microservices architecture, I should be using two different databases for news data and weather data for two microservices. But then according to the rules AWS asks us to follow, there should be ideally only one database, because since a NoSQL database, you could just add items as key, and you could, add just new columns as strings. So you don't really need two databases. One database is enough for manipulating or adding new data. So that's about it. I think I have included a detailed report, since we are just supposed to record the video in 5 minutes. Everything else would be in the report. Thank you so much.